See nomenclature of organic compounds. Lecture series L-3, naming of aliphatic saturated hydrocarbons. In this lecture, we focus on selection and numbering of parent chain in aliphatic saturated hydrocarbons. Aliphatic saturated hydrocarbons are also called alkanes. They contain all carbon-carbon single bonds. There are rules in selection of parent chain and numbering of carbons of parent chain. Select the longest continuous carbon chain with a maximum possible number of carbon atoms, and this carbon chain is called parent chain. Other than parent chain, remaining are called substituents. Parent chain should have maximum number of possible substituents along with maximum number of possible carbon atoms. It means that if there are two longest continuous carbon chains with the same number of carbons, then select that longest continuous carbon chain with maximum number of substituents. Let us see the first example. 1, 2, 3, 4. Here 4 carbons are continuously connected and there is no other possible longest carbon chain. We should not stop at 1, 2 and 3 because next to this carbon there is 4th carbon continuously connected. Therefore, this is a parent chain containing 4 carbons. Please note that here there are no substituents. In the next example, 1, 2, 3. There are 3 carbons which are continuously connected. So, this could be one parent chain. Now, it is a straight chain. Parent chain need not always be straight. See here 1, 2 and 3. There are 3 carbons which are continuously connected. Now when we choose this is our parent chain, then there is one substituent, that is methyl. When we choose this as our parent chain, then again one substituent, and in fact both are same and of course identical. Either of the chains can be taken as parent chain. Now in this example, 1, 2, 3, 4 carbons are continuously connected in this chain, and here 1, 2, 3, 4, 5 carbons are continuously connected. We must choose the parent chain as one that has maximum number of carbon atoms. Therefore, this is a parent chain, this is not a parent chain. Always choose a parent chain as that with maximum number of carbon atoms and then only with maximum number of substituents. Let us see this example. Here 1, 2, 3, 4, 5, 6 carbons, they constitute longest chain. For the same molecule, another continuous carbon chain can also be drawn. 1, 2, 3, 4, 5, 6. There are 2 continuous carbon chains with maximum number of 6 carbons. Then what is the difference? When this is chosen as a parent chain, it has 1, 2, 3 substituents. When this has been chosen as parent chain with the same number of carbons, there are 1, 2, only 2 substituents. When there are same number of carbon atoms, then we choose that as a parent chain with maximum number of substituents. This is a parent chain, this is not a parent chain. Now we are going to the next rule. Number all the carbon atoms and parent chain from 1, 2, 3, 4 and so on. The number that is given to the carbon is called locant. Numbering is carried to give lowest possible locant to the carbon that contains substituents. Here, this is a parent chain, but there are no substituents. We just therefore can give numbering in any way 1, 2, 3, 4. This is correct. Or 1, 2, 3, 4. This is also correct. Now we have chosen here any two possible chains. Any possible chains. Let us say this is one such possible chain. Now numbering can be done in two ways. Let us start from this carbon 1, 2 and 3, and in this case this is a parent chain, and let us give numbering 1, 2, 3. Here there is a methyl substituent which gets the locant 2. Here the methyl substituent again gets locant 2. A very important caution, we have to check the numbering not only in one direction but also in another direction. Let us start numbering in another direction 1, 2 and 3. Here also methyl group is getting identical locant. Therefore, numbering can be done in either way. Both are correct numberings. Now, here we have chosen the parent chain as the longest continuous carbon chain. Now, let us start giving numbering starting with this carbon 1, 2, 3, 4, 5. Therefore, methyl group got the locant number 3. Now, let us give the numbering in opposite direction. The parent chain contains 5 carbons. Now, numbering in opposite direction 1, 2, 3, 4, 5. So, the numbering in any direction is giving same locant, and therefore both are correct. And of course, both numberings are identical. Now, let us choose parent chain. Here the parent chain is a continuous carbon chain. 1, 2, 3, 4, 5, 6, 7, 8. In this direction 1, 2, 3, 4, 5, 6. Or in another direction 1, 2, 3, 4, 5, 6, 7. Therefore, the longest carbon chain is the parent chain, which contains total 8 carbon atoms. Now give numbering. Let us start from here 1, 2, 3, 4, 5, 6, 7, 8. Then this group, also called isopropyl group, takes the locant number 4. Now let us give numbering in opposite direction 1, 2, 3, 4, 5, 6, 7, 8, and see that the isopropyl group now got locant 5 in this direction. When going in this direction, the locant number for isopropyl group is 4. When numbering is done in this direction, the locant number is 5. As rule says, the locant should be as minimum as possible. The numbering in this direction is correct and in this direction is incorrect. Rule number 3. If there are more than one substituent, then numbering is done to give lowest set of locants to substituents. Now select the parent chain. Here the parent chain is the longest continuous carbon chain that contains 5 carbons. I have written the molecule 2 times, therefore the numbering can be shown in 2 different ways. Let us start numbering from this carbon 1, 2, 3, 4 and 5. Here the set of locants are 2 and 3. Now let us give numbering in opposite direction 1, 2, 3, 4 and 5. Here set of locants are 3, 4. While comparing set of locants, always first compare the lowest locant. In this set of locant, the first locant is 2, and in this set of locant, the first locant is 3. Just go on comparing the successive locants until you get to that set of locants with the lowest locant number. Here first locant itself decides which is possible lowest set. Here we got a 2, here it is a 3. You need not to consider 3 and 4 while comparing which is the correct numbering. Always go on comparing first locant and then the next set of locants. Therefore, this numbering is correct and this numbering is wrong. Let us practice one more example. Here careful, longest chain could be 1, 2, 3, 4, 5, and here another possible 1, 2, 3. Please note that this is a ethyl group which contains 2 carbons. So 3 after 4 and 5 carbon. But whenever we have chosen this 5 carbon chain as a parent, we got only one substituent. Now let us choose again one more longest carbon chain 1, 2, 3, 4 and 5. Again this also has a 5 carbon longest continuous chain, but it delivers 2 substituents. Therefore, the parent chain is the longest carbon chain with maximum number of substituents. Now give numbering in 2 ways 1, 2, 3, 4 and 5. Let us give in opposite way 1, 2, 3, 4 and 5. Now the set of locants are in this direction. We have 3 and 4. The set of locants for this direction are 2 and 3. Just by comparing, here it is 3, here it is 2. As 2 is smaller, the correct numbering is this direction. This is not the correct direction of the numbering of carbons. Rule 4. Substituents are known to be in identical positions if the same set of locants are obtained. It means that when the set of locants are written in either direction, then we get the same set of locants. As example, 2, 3, 7 is one set in one direction. When numbering is done in other direction, we got again 2, 3, 7. Then we say that the substituents are having identical locants. In such a case, numbering is done to give lowest locant to the substituent whose name comes early in the alphabetical order. Here a very important note, as from 1993 recommendations, in alkyl substituents we have secondary and tertiary. We don't consider S of the secondary and T of the tertiary in writing alphabetical order of alkyl substituents. Let us see the example. Here This is the longest carbon chain containing 1, 2, 3, 4, 5 and 6. It has two substituents, methyl as well ethyl. Now give numbering 1, 2, 3, 4, 5, 6 and in opposite direction 1, 2, 3, 4, 5 and 6. Now write the set of locations in this direction. The set of locations are 2, 4. In this direction the set of locations are 3, 5. As 2 is smaller than 3, this direction of numbering is correct. Now let us take one example. CH3, CH, CH2, CH2, CH, CH2, CH3. Here it is a straight chain, longest carbon chain contains 1, 2, 3, 4, 5, 6, 7. As there are no substituents, numbering has no importance. Let us take this example. CH3, CH, 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 CH3, here C2, H5, here CH3. The numbering is done from 1, 2, 3, 4. But this is in fact not a parent chain. Please look at here carefully. 1, 2, 3, C2H5 has 2 more continuous carbons. So this is a longest continuous carbon chain. Now to justify this rule, consider CH, CH3, CH, C2H5, CH2, CH3, CH2, CH3. Here the longest continuous chain has 6 carbons. Now start giving numbering 1, 2, 3, 4, 5, 6. In opposite direction 1, 2, 3, 4, 5, 6. Now write the set of locations. In this direction the set of locations are 3 and 4. In this direction the set of locations are 3 and 4. But here substituents are methyl. So this is methyl and here it is ethyl. Both are not same substituents, but as set of locations are identical for both the substituents, now numbering is done. Therefore that group which comes earlier in alphabetical order will get lowest locant. Here methyl M and ethyl E, methyl comes early in alphabetical order than ethyl. Therefore methyl should get lowest locant. Therefore the numbering must be done in this direction. This is a correct numbering. This is not correct.